In the previous lecture, we have calculated equation number 8 and equation number 9. Here, if you see these two equations, we have cosine of nu t. And this cosine of nu t, we can write iota nu t plus e to the power minus iota nu t divided by 2. To simplify further these two equations, we must take cosine of theta in an exponential form. Let's consider equation number 8. C a dot of t, which is equal to e to the power minus iota phi, e to the power iota omega a b t, cb of t, and cosine e to the power iota nu t, e to the power minus iota nu t divided by 2. Further, iota omega r divided by 2, I can take 2 here, and e to the power minus iota phi, cb of t, and multiply this thing with this, then iota omega a b t plus iota nu t, and multiply this with this, we have iota omega a b t minus iota nu t, and ca of t, which is equal to iota omega r divided by 2 cb of t, and here iota omega ab plus nu t plus e to the power iota omega ab minus nu into t. It should be noted here, this omega ab, we know this omega ab is the transition frequency, and this nu is the field frequency. Nu, this is the field frequency, the applied field frequency, and these both are in the order of 10 to the power 15 hertz. And if we add these two powers, these two frequencies, then the exponential term will oscillate very fastly. In the recent time, we have no any device to measure such kind of frequency, and we must remove this highly oscillating term. And this highly oscillating term, if we ignore this, then this is known as rotating wave approximation. The rotating wave approximation means that this term is oscillating very fastly, and there is no any device to measure such kind of frequency. So this term, we must ignore this term. Then we have ca dot of t, which is equal to iota omega r divided by 2 e to the power minus iota phi cb t, and exponential iota omega ab minus nu and t. Now this is reasonable. Similarly, we can find in such a way by putting cosine nu t here, and we can find out the value of c dot b, which is equal to, this is very similar to this, and here iota omega r divided by 2, this phase must be this one, this is ca of t, and this term e to the power minus, this will be minus e to the power minus iota omega ab minus nu into t. Now we further have two equations, and this equation number 10 and this is equation number 11. Now we have two equation number 10 and equation number 11, and further how to solve these two equations. We have an exponential omega ab minus nu, and this is very important term. If consider we have a two-level atom like AB, and here this frequency is omega AB and this is known as transition frequency, and if we have an external field whose frequency is nu, whenever this frequency is exactly matched with this frequency, it means omega AB must be, if this is equal to nu, then we can say that omega AB minus nu, which is equal to 0. And this is known as resonant condition, resonant, because this frequency becomes equal to this frequency and this is known as resonant. But sometime it is possible that this frequency is less than this transition frequency, and sometime this frequency is slightly greater than this transition frequency. And you also know that when the transition frequency match with the external field frequency, then this is allowed interaction. This will interact with these two levels. But whenever the field frequency is very large as compared to the transition frequency, there will be no any interaction. And similarly, if the field frequency is very low as compared to the transition frequency, there will be no any interaction between the level and this frequency. But slightly difference is possible. If this is slightly different with this, means if this frequency, this transition frequency is slightly greater than the field frequency, then this is known as omega AB minus nu, which is equal to some detuning. This is known as detuning. And it is also possible that this frequency is slightly greater than this transition frequency, then we may write this nu minus omega AB, which is equal to detuning. And we can also say that omega AB minus nu, then we have a negative sign and this negative sign will be like here. So this is a negative detuning and this is a positive detuning. This is a positive detuning and this is a negative detuning. So detuning means the detuning means the difference between two frequencies is known as detuning. The difference between two frequencies is known as detuning. The difference between two frequencies is known as detuning. So this is an important point. To incorporate detuning in these equation number 10 and equation number 11, we can write this as Ca dot t, which is equal to iota omega r divided by 2 e to the power minus iota phi cbt and e to the power iota, and putting the value iota delta t. This is equation number 12, and c b dot of t, which is equal to iota omega r divided by 2 iota phi ca of t e to the power minus iota delta t, and this is known as equation number 13. This is equation number 13. Further, we have to solve these two equations. You can solve this because these are two coupled equations. You can solve this by using a Mathematica as well. But here I would like to solve this in some another method. Let's differentiate this equation again with respect to t. Equation number 12. Take derivative of equation number 12. If we take the derivative of these two equations, equation number 12, then Ca dot double dot, which is equal to iota omega r, this is time independent, these terms, but cbt and these are time dependent, this is a time dependent and this is also time dependent, then we must use the product rule, and this c cross bt dot and e to the power iota delta t plus this term iota delta and e to the power iota delta t and c b of t. Now, if you look this equation cbt and cbt, this equation is NCA, and this is CBT, and this is CB cross T. So we must take this whole equation and CA cross CB dot. We have this equation. So putting the value of CB from equation 13 here and CB cross. We can find out CB cross from equation number 12. Let's see, iota omega r divided by 2 minus iota phi. What is the value of CB? So the value of CBT, C dot BT from equation number 13 as iota omega r divided by 2 e to the power iota phi and Ca and e to the power minus iota delta t, and this as iota delta t, then plus iota delta e to the power iota delta t, and the value of Ca of t dot 2 and 1 over iota omega r and e to the power iota phi and e to the power minus iota delta t. So this is the value for CBT, and we can calculate this from equation number 12. Ca dot double dot iota omega r divided by 2. These two terms, this exponential plus minus plus, and here this is a plus and this is a minus, because if we multiply then the exponential will add and these will be equal to 1. And here iota omega r divided by 2 e to the power iota phi and Ca of t. And here this iota can be cancelled out with this iota, this one and this one, and we have 2, this 2, delta CA of dot t and e की power iota phi, and divided by omega r. I think this will be the final 2 delta CA dot exponential. It's okay. Further multiply this term with here, then you can get, multiply this with this. Let's see, if you multiply this with this, then this will iota square minus, then we have minus and omega r square divided by 4. This term multiply with this 1 and CA of t. If you multiply this with this r will, omega r will cancel with this, and 2 will cancel with this. Then we have iota, and this exponential will cancel with this. So we have iota delta and CA dot of t. Maybe this will be the final, result. Iota delta, yes, this is the final result. And further, CA of t, which is equal to, if I, let's say, let's consider CA double dot minus iota delta CA dot plus omega r square divided by 4 and CA of t, and which is equal to 0. And this is the second order differential equation. And we can solve this because this is d square CA of t minus iota delta. This is a d. D means derivative of this. C of t plus omega r square divided by 4 CA of t, which is equal to 0. D means d divided by dt, and d square means d square divided by dt square. Equation S, characteristic equation S. M square minus iota delta m and plus omega r square divided by 4, which is equal to 0. This is the characteristic equation. And the solution of this characteristic equation is some quadratic equation, and this is known as iota delta plus minus and minus delta square and minus omega r square divided by 2a2. So this is the quadratic equation, and here this is minus, then I can take this minus 1 under root, and this is equal to iota delta plus minus iota and delta square plus omega r square divided by 2. And consider delta square plus omega r square. This is by, we consider that this as omega. Then m, which is equal to iota delta plus minus iota omega divided by 2. M iota delta plus iota omega divided by 2 and iota delta minus iota omega divided by 2. And the solution of this is, the solution will be Ca of t, which is equal to a1 some constant e की power iota delta plus omega t divided by 2, and the other one solution is this and the other one is e की power iota delta minus omega t divided by 2. And also this equation can be written Ca of t, which is equal to a1 e की power iota omega t divided by 2 plus a2 e की power iota minus iota omega t divided by 2, and if I take common iota delta t divided by 2. And this equation is equation number 40. Ca of t, which is equal to a1 e की power iota omega t divided by 2 plus a2 e की power minus iota omega t divided by 2 and exponential e की power iota delta t divided by 2, and this is equation number 40. In a similar way, you can find out Cb of t. You must consider Cb of t here and differentiate this with respect to time, double derivative of this, then you have Ca of t and this. The same process you can apply for equation number 13 and putting the value of this, and you can find the value of Cbt like this. And I would like to write this directly. Cb of t you can calculate in a similar way. This is not a complicated one. You can find this equation and b1 e की power iota omega t divided by 2 plus b2 e की power minus iota omega t divided by 2 and e की power minus iota delta t divided by 2, and this is equation number 50. Now you have final two equation number 14 and equation number 15, but still these equations are incomplete because here you can see a1, a2, b1, b2. We have two equations and four unknown values. Here a1, a2, b1, b2 are constants. And to find these constant, we apply the initial condition. Applying the initial condition. Initial condition means when time t is equal to 0. At time t is equal to 0, equation number 14 and equation number 15 will take some form. At time t is equal to 0, equation 14 and equation 15 takes the form as. At time t is equal to 0, this equation Ca of 0, which is equal to, the exponential term will be equal to 1. Then we have a1 plus a2, and Cb of 0, b1 plus b2. Now we have further two equations 16 and 17, Ca of 0 this, Cb of 0 this. And now we are interesting to find out the value of a1, a2, b1, b2. To solve this problem, I would like to consider equation number 30, equation 30, this equation. And this equation as Cb of t dot, which is equal to iota omega r divided by 2 e to the power iota phi Ca of t and e to the power minus iota delta t. So I have considered here equation number 13 and putting the value of t is equal to 0, the initial condition. The initial condition at time t is equal to 0, this equation can be equal to iota omega r divided by 2 e to the power iota phi and Ca of 0. Now, if I find out Ca of 0 from this equation, then this is equal to, this term will go to this side, 2 divided by iota omega r e to the power minus iota phi and Cb dot. If we differentiate this equation now, differentiating equation 15, then equation 15 Cb of t dot, which is equal to b1 iota omega divided by 2 e to the power iota omega t divided by 2 plus b2 minus iota omega divided by 2 and e to the power minus iota omega t divided by 2 and e to the power minus iota delta t divided by 2. And further differentiate this iota delta divided by 2 and e to the power minus iota delta t divided by 2, and the same term e to the power iota omega t divided by 2 plus b2 e to the power minus iota omega t divided by 2 is equal to 0. Now for t is equal to 0, this Cb dot 0 must be equal to, this is equal to 0, this 1, this 1, 1, 1 and 1, and we can get iota omega divided by 2 b1 and minus iota omega divided by 2 b2 and minus iota delta divided by 2, and here is b1 plus b2. Now here b1, and further this equation can be written because here b1 and here is a b1, then we can take b1 common, and here iota omega divided by 2 minus iota delta divided by 2 b1 and minus iota omega divided by 2 plus iota delta divided by 2 and b2. And now putting this equation, the value of this equation in equation number 18, putting the value of CB dot this value in equation number 18, this equation, and CA of 0 will be equal to 2 divided by iota omega r e to the power minus iota phi, and the value as iota omega divided by 2 minus iota delta divided by 2 b1 minus iota omega divided by 2 plus iota delta divided by 2 b2. In this CA of 0 e to the power minus, let take LCM first, e to the power minus iota phi. The LCM of this is 2, and iota omega minus delta b1 minus the LCM of 2 iota omega plus delta and b2. And now multiply this term here, then e to the power minus iota phi, multiply this 2 will cancel with this, and we have iota will cancel with iota, omega minus delta divided by omega r into b1, and similarly 2 will cancel with 2, iota with iota, then omega plus delta divided by omega r and b2. Equation 17, we can find b1, which is equal to cb of 0 minus b2. Putting the value of b1 here, then CA of 0 e to the power minus iota phi and omega minus delta divided by omega r, and b1 as CB0 minus b2 minus omega delta this thing. Now we have b2 and b2, and CA of 0, which is equal to e to the power minus iota phi and omega minus delta divided by omega r, CB of 0 minus omega minus delta divided by omega r into b2 minus omega plus delta divided by omega r b2. So here you can take, you can add these two, because this is minus minus, then if you take a b2 common, then what you can get from this, so CA of 0, which is equal to omega minus delta divided by omega r and CB of 0, and let take b2 common, then omega minus delta divided by omega r minus omega plus delta divided by omega r, and let, if we take common minus, then this will be equal to plus, and b2 and e to the power minus iota phi. Let's take the LCM, omega minus delta omega r CB of 0. The LCM is omega r, omega minus delta plus omega plus delta b2 and e to the power minus iota phi, and CA of 0, which is equal to omega minus delta omega r CB of 0, and here this detuning will cancel with this, and plus minus, then we can get minus 2 omega divided by omega r and b2 and e to the power minus iota phi. Further, omega r can be, we can take this common, omega r, omega minus delta cb of 0 minus 2 omega b2 and e to the power minus iota phi. Now from this equation we have b2 here, and we can find out this b2 from this equation. Here omega r, we can take this to the left hand side from omega r, and also this term equal to this, and ca of 0, which is equal to omega minus delta cb of 0 minus 2 omega b2. And this term, if I have to find out this b2, then I can take this here and this side, then 2 omega b2, which is equal to omega minus delta cb of 0 minus omega r e to the power iota phi ca of 0. And further, b2 will be equal to 1 over 2 omega and omega minus delta cb of 0 minus omega r e to the power iota phi ca of 0. So this is the value of b2. If we have the value of b2, then we can find out the value of b1 as well. The value of b2 in equation 70. We can get b1 like this. I can write this cb of 0 directly, and minus 1 over 2 omega, this omega minus delta cb of 0 minus omega r e to the power iota phi ca of 0. So we have the value of b1 and b2.